Oh, hello there. I guess I'm on the air. I figured I haven't uploaded a video in a while, and I don't really know. I don't have a topic or anything, but I thought that just as a little aside, I mentioned this little bit of code I added to the string class, and well, for a couple of reasons. One is one member, or not member, subscriber, I guess, uh, was asking about something related to this. He downloaded the code and was curious about the use of some of the declarations in the string class, TsString. So once this person was curious about where they're not declarations, they're typedefs, but if you're not used to seeing typedefs, and especially in this form, you might wonder what the heck is this, and what am I supposed to use it for? And my answer was, well, it's internal, and you don't worry about it. But there, something came up, and I needed to use one of these, so I might as well show how it came up and how it works, how this works. The problem being the non-terminating work on my little this program. Okay, it should have just come up. Control-H. Didn't come up. Oh, it's not set up on this view. Here somewhere. This program has these little text things I can do. Like, okay, just write any text. Alright. And then, but then there are things I can do that are similar to formatting options. Like you see that that's in italics, right? I could say, now the default's italics, so to turn off italics, I can do /I, as if you would normally turn on italics. And then /I turns the italics back on. So here you see I have some ability to do some formatting. Also, there are things like subscripts and superscripts. I could say e to the x, the function. See? And it actually looks not bad. These, you can do quite a lot with regular fonts and the subscripts and so on that are granted, especially to people who are lucky enough to live in Cambodia. If you live in the United States, this may not work. But you can always lie. You can always say you live in Cambodia, and then you'll get access to all these wonderful things. For instance, one of them, I didn't realize it would work so well, is like this one, to the I. Okay. Now the reason this is important is for complex numbers, but there's no superscript apparently. There's no superscript character for I. Well, there isn't really, but there's, on this font anyway, there's a superscript I, which they just convert to a superscript. I have it listed in the file. I have them all listed. I'm getting double clicks for my single clicks, and I still can't double click with the record. No, these are subscript. Right? It's semicolon underscore. That prefix means sub, and then a letter. So here are the numbers, and superscript is semicolon and then a hat. And there's all kinds of things. If there's an equal sign, a minus sign, plus, you could do all kinds of things. And almost all the letters, see? And here's that funny I. It doesn't actually appear. The reason, you see that the cursor is here? The reason for that is this character has a very strange behavior. If I get rid of this space, you see? The line has disappeared, and I can type stuff here. Oops. Behind the funny character, oops, and I've done this before. Maybe I don't use I. How do I do it? I was able to write a whole, well, everything there is missing, right? Okay, here I'm writing, here I wrote it. If I'm behind that equal sign, I guess I'm okay. So here is a secret message that nobody can see. I just wrote a secret message. And if I want to reveal the message, I do that. See? Now, why that works that way, I do not know. That's a very strange character. I leave the space here so that I know it's there. It doesn't even show me this part. Anyway, superscripts and subscripts. Now, sometimes I want combinations, and so I thought of this syntax without the semicolon slash hat, and then it's just literal. It'll just look for this sequence of characters and replace that with this. These are superscript characters. That's for, you want to say, what was it again? First, or the 25th, or 21st thing. And it comes out pretty good. And it's just lucky that there happen to be enough superscript letters to cover these four, because that's all you need. The way it works is first, second, third, and then everything after that is th until you get to the next round of 10. 0 goes with th, right? No. Yes, like 10th, 20th, 30th, and then things ending with 1 always have st, and 2 nd, and there are no other. You only need these 4. So there's a plethora of things you can do on the superscript side, like and this is just using the font. Like Excel or Word or anything. You could write down an equation like I don't know, x to the I don't know, a bracket a But for each one, I've got to repeat this upper. Oh, now, do I have the Greeks? I don't have the Greeks up here. I can do Greek upper. I'm not sure how this is going to work out. Almost. I wanted to do a plus I sine x, but you notice there's a space there. And I don't think I can get rid of this. Oh, okay. So here, that looks like a, I can put the Greeks up here too, but I don't have key bindings for the upper Greeks. They are there, they exist. You can't convert one. If I added if I can just grab one, yeah, it doesn't matter. You can see where I'm driving at is that there's a lot of flexibility in the uppercase arena. Many characters, Greek, Latin, symbols, plus, minus, equals, all kinds of stuff. But for the subscripts, there's almost nothing. It's terrible. There's an N. I started putting it in. There is a character N, right, for subscript N, but it doesn't work. None of the fonts support it, at least for a Cambodian. Maybe if I claimed I'm from Zimbabwe, I would get it, but I don't know what country is best for getting subscript N, which would be the most useful mathematical one, right? It does exist. You can find it. Well, it's listed, but all you get is a square box. But on here, you don't get a square box. The character appears, but I don't know what font is displaying it. It's not under subscripts. It's under something else, I think. It's not. It won't come under subscript. I ran across it by accident. I just saw an N. Here they are. See, it's not under subscripts. It's under, what's this category? General punctuation. All right. I thought, oh my God, thank God. Subscript N. I'll just copy that, right? And I'll just test it out here, and that's what I get. A little box. But if I use this special magic font, suppose I wanted to copy that character into here. This is using I can't. It's read only at the moment. So I got two of them going. You copy it into here. Okay, see, now the reason why it's working in here is because I downloaded a special font. And that's great and everything, except it's this deja vu font. It has that's a subscript, right? But everything else looks terrible compared to the font that I'm using. I don't want to switch from this font. So I know this is a long story. I'm making it too long. I already have a thing for that italics you saw, right? So I thought, okay, what I'd like to do then is just add a similar, maybe slash sub or something, right? A sequence to say now switch to subscript mode, and all I do is just use a smaller font. This changes the font, a font, right, to a non-italic font. The subscript thing would do the same. So what I wanted to do then is here this thing searching for the open italic marker. I'm going to add a new marker for another thing, and then I want to be able to search for this marker or the other one, whichever comes first, right? Now, turns out in the same file, I have exactly the same type of problem where I've got a bunch of keywords, and I have this code here that runs through the keywords and looks for the first occurrence of one of these keywords in a string. There could be more than one keyword. I want to find the first match. So here's this code. Now my tolerance level for rewriting the same code is exactly 1. So I'm not going to rewrite this code again. Either because I'm just obsessive or something like that. But I don't think it's obsessive. I've learned over time that writing one piece of code a second time is definitely way too many times to write that piece of code, and it's gonna be trouble down the road eventually. Even one duplicate of a piece of code is just guaranteed it's gonna hit you. So I'm not gonna rewrite this. I'm gonna make it a single function, and I thought I might as well add that TsString. So I just want to add a FindSubstr type function that takes an array of strings, right, and returns to me the index of the first occurrence of the first string in the array in my string. And I called the function, gave it an obvious type name. I double click, wow. FindFirstSubstr. See? And here is an array of substrings, and here is a string, and this thing will return either -1 if not found, or the index of the first occurrence of one of these strings in my string. Simple enough. But there are a lot in this. In writing this function, there are a lot of extra little tidbits that one might find useful, so I thought I'd make this video. First off, this here is a case-sensitive search. Okay, I don't know if this is compiled. Yeah, it's compiled. Now here are the strings. As is with a capital Y, LO. So here's an LO, and hello world. Hello world's a magical string. Okay, well, hello world is definitely in my string, and it matches the case of this. Low as well is in this string, also matching in case. Is, but it doesn't match the case. As, do I have an as? I don't see any as. And that's it. So the answer in this case should be hello world, right? So if I found is not equal to -1, what I'm going to do is print out the string starting from the found position to the end. It should print out how starting from here to the end of the string, which it does. Okay. Now if I have another. Okay, now here's one thing before going on. This is one of the things that bugs me about these sorts of functions, where here's a variable that I've created in order to store the return value of this function. I make one comparison with it, use it, and now this variable, I have no more use for it. I don't want it anymore, right? And one might even get tempted later on to reuse this variable for some other purpose. And people will do that. I've even on occasion done that and corrected myself pretty soon afterwards. You should never do that. Suppose later on you have exactly the same code, right? But for a different string. You might say I found equals stir1, find first substr, and maybe you have a different list, or maybe it's the same list, right? This here is wrong, spelled wrong, right? The reason for that is because not because it's invalid code or anything, but because somebody in the world, and if you're working in a company or something, is going to read this and wonder, well, where's this I found declared, and eventually they're going to find it. This could be lots of code, a million miles away, and they find it declared up here. Now, immediately the first thought that comes to mind is, well, what's the meaning of this I found, right? Like, is it something that's being kept track of? Do we need to maintain it, save it off, whatever, right? You don't know, as a person walking in to this code and seeing a variable that has persisted for ages and ages being used, you don't know immediately that really all that's happening here is this is being used like a temp over and over again. So you should never do that, because it's not totally clear to the person who doesn't know that this is only being used for this one purpose. You would make up a new variable, I found 1, and do it like that. When someone sees this, they see the declaration and they know that it has not been used above, and that it can't possibly be have any effect on anything else. It's not it's not some part of some ongoing accumulation or something like that. So just telling you, don't do that. Declare your variables and use them, within a couple of lines. And if something is persisting for some reason, right, then you'll know when those cases arise, because you'll see that a variable will be used and you won't see its declaration. So therefore, that's something that has a meaning that is meant to persist. Anyway, so that's one lesson. One way to solve that problem, though, is to not have a variable, right? If you could get rid of this variable completely, then you never even have to worry about that. Now, wouldn't it be great, if you could do this, right? Just have it in the scope of this, only valid in here, and then the I found can be used again outside here for another purpose. That would be great, wouldn't it? Problem is, it doesn't compile. Now, I have a trick for this, by the way. I'm going to show you that one in a minute. But first, if this thing would ever compile or fail to compile, I can at least demonstrate to you. Okay? It's not happy because of these brackets, and you can't make the comparison, blah, blah, blah. Right? However, for this one, turns out this function, like all of these other functions, return -1 when it doesn't find the substring. So, and it also turns out that you can declare a variable in an if statement. And whether the body of the if gets entered depends on whether or not the declaration amounts to non-zero or zero. So if you wanted to be really clever, you could do this. That'll compile. Only problem is I found will be one more than it should be, so you have to put this here. Now that you don't have to check for I found being 0 because there's no possibility of entering in here I want to enter here when I found is not equal to -1, right? Right. So when it's equal to -1, this here evaluates to 0, and that it won't come in here, right? I mean, when this thing returns -1, sorry, not I found. When this whole thing returns -1, I found here would turn into 0, which would normally be -1, but now that's been excluded because the if takes the expression as being this plus this, and -1 plus 1 is 0. So this actually compiles. And I found doesn't exist out here. I can't use it here. If I tried to. This will fail to compile. So that kills two birds with one stone. I don't have to worry about redeclaring variables. It's only valid here, and it would be valid also. It would be valid inside the else. This will compile. And there's only one possible value that it could have if it comes in here, and that would be 0. I could say that. I can say that with certainty, and we could reproduce it too. Here, if I run this, something will be found what is it? Hello world. Hello world will be found, so this won't be 0, and this will print out just as before. But if I, let's say, make this a cap, kill both of them, make this L a capital, then nothing will be a match. Right? In this case, that kills the low, that's not a match, and hello world's not a match. Neither is as or is if it's case sensitive, which it is. Okay, oh, low. This is supposed to be case sensitive. No, that's not right. Oh, LD. Oh, LO. Whoops, wrong L. Make this one uppercase. This has no matches. But you saw that worked, right? I killed the hello world, and it advanced me to the next possible match. So you can see that the substring search thing is working fine. And then when I get to how that works in a minute. Okay, we got 0, which is what we expected. And I should have a character here. Okay, now the other thing is if I put an I here, then now it becomes a case insensitive search. So now as there are none is insensitively, this is a match. So this one should print out starting from this point onwards, turns out. Is, right? Hello world, etc., etc. There it is. Okay. Now I'm printing out the string, not these characters. And that's one of the problems with this function, is that it's not telling me. It is finding the match, but it's not telling me which of these the match is, and so I've got to look again at the string and find out what matches. So, so I added a parameter that I can pass in if I like another value that will tell me the index of the string found. Unfortunately, I did it. This here has 2 default variables rather than, ideally, I don't want to specify this start position, but I have to. If I'm using default variables, another solution is to use just make more functions with different combinations. But these are both int. Well, so no, one's a pointer. Could do it. So an address of, let's say we call it index, which we will have to declare again. Now again we have a variable used only once and lives for the rest of eternity in our program. Another solution, by the way, of course, is to just put the whole thing around curly brackets, and that'll kill off those variables. And I do that too, actually, quite often, just to make sure that I know what's being used where. Okay, now this one tells me the index of the match that was found. Okay, So what I can do, if I wanted to demonstrate which one it was, is I could just, well, I could print out the match, right? I could print out this if I wanted to. Like that. This doesn't tell me where it is in the string, but I've got that information too. Let's just see that this works. And you might be asking yourself, how come I can have an array of 4 strings and I've not specified that anywhere? And that is another part of this. Okay, so the match was is. I could put beside that and then print out I don't know, does that work here? Or I could quote the rest of the string. Plus do new I found, and that's it, right? Minus 1. And then plus another quote. Actually, I don't think I need this to be a TS string. If you've got 1 in there, it should be able to work it out. 1 string object. Here, this is a TS string, and it shouldn't try to do this addition first. It should try to do this addition, which results in a TS string, from which it can add that and then add that. So it should compile, I think. If not, then I'm going to make a note that both of them TS strings. I'm not sure what the rule is. It failed, yeah. Okay, so it's a left to right addition. I could just put these in brackets. That would do it. It can add this to this. It'll evaluate this one first, and then the rest can proceed. So I didn't have to make a second string thing. Okay, so where to go? So it is at, and here it's showing in the string where the is was found. And if we do like a case sensitive search, we're going to find anything? Yep. Because I'm going to make that capital. This will find hello world. Or I should have maybe added another is or something. Or 8 high or something like that. Anyway. We've only seen 2 of them match. I can change that. I want to see another one fire. How about before hello, hi. That's right at the beginning. try that rattle match before hello world. This one, to ensure that you can see that all of them are getting tested. We're getting our result back. And we know which index, we know the index of the substring that matched, and we know where it matched, right? And so that's great. And we can do it with, oh, my mouse. Everything's a double click. It can be case sensitive, it can be all these things. Well, how is it possible to write such a seemingly complex function that does all this stuff so seamlessly? Well, we use templates, naturally. There are two versions of the function. One has an I at the end for insensitive, and actually the two functions look identical. They are essentially identical. The only difference in these two functions is the inclusion of the letter I here, turns out. So you'd think maybe I could even compress this somehow. I could turn it into a number. I could make a number define and turn it into a single statement, but that's no good. You can't step in. Alright. So it doesn't matter which one we look at, it's exactly the same. Here's the function. It has two default parameters. N here is the starting index of the search. This is an index that optionally provided a pointer to an integer if the index in the array is required. Okay, now in order to not have to do cases, I've declared an integer reference here, which is equal to either, if this index thing pointer is non-null, then it's just star of that. That gives a reference to an int. Okay, otherwise I'm just allocating an int here on the stack. It's alloc A. So there's a lot of things that you might not know about that you can do that makes this a good example. Alloc A is like malloc, okay? However, the memory allocated by alloc A is freed when the function returns. So this is a temporary int. Okay, I could have declared a temporary int and done it that way, but this way I don't need to declare a variable name. See? Another case of not having to make up a name for something that's only going to be used in one line and needn't persist any further. And whatever this does resolve to is stored here anyway in this variable, right? P index passed in does persist, but nobody needs to use it, after this point. One could, if one wanted to, also get rid of this name by taking the address of start here, right? Put ... here and then use variable argument, and anyway. Then okay, now the job, where's the work being done? Well, the work's being done in a similarly named function, FindFirstSubstr, which is a private function which takes an array of this many elements, a starting index, an array index reference to return the index of the found object if it finds one, found substring, and a comparison function for the search. Okay, now here I have an assortment of various functions for searching for substrings. This one just searches for a character, but a character is a type of substring. And I have one that is a case-sensitive version and one that is a case-insensitive version, and they both have the same format, right? And that format is the format indicated in this type declaration here. Locator, something that locates, M for member. This is a member function that returns an int, takes a string, and an int starting position turns out, and that's what those two finds are exactly of that form. So one of them, what is it? It's my new function. One version of this function passes in this locator function to be used, and the other one passes in this locator function to be used. Looking at this function, which is not that, the compiler gets confused. By this point, it's very confusing for the compiler, but here it is. Here's a declaration. Now, actually, another important thing, very important, extremely important, this here, there must be a const here. And the reason for that is a subtle one. There's two things that can be modified in this array, right? One, the content of the strings being passed in, which we don't intend to modify. And then there's the array itself, which we don't intend to modify either, right? Having this const here indicates that we will modify neither of those things, right? And I have the same thing repeated out here. Const. The reason for that is because if I didn't have it, suppose I forgot, okay? I did like, anybody at SourceForge, well, they don't even bother with this const. They don't even bother with this one. But a conscientious programmer knows to put their consts where required. If I did this, you might think, okay, well, it's the same function. It doesn't matter. I'm not modifying it anyway. Who cares if I declare it that way, right? And everything's going to compile. It'll compile like this. But that's looking at it from the point of view of the function writer. That's the person writing the function's point of view. From their point of view, not putting that const there is perfectly fine. They know that they're not going to modify those things anyway, and so there's no need for it, really, right? So why put it there? But if you look at it from the point of view of somebody who might be using your function, then you've committed a gross error. And why is that? I'll show you in a minute. This here compiles and runs fine. But if my If my array of strings happens to be declared the way I would normally declare an array of strings, then it won't compile. It won't compile because I'm not allowed to pass this constant array of strings into a function that intends to modify the array. By not putting const, that is a declaration of intent to modify. See? Not allowed. Oh, actually, it failed. Couldn't do it. And that's correct. It should fail because I've said this array cannot be modified, and this function is saying, sorry buddy, we're going to modify it, but it's not going to modify it. So you must make sure to say, I'm not going to modify that array either, neither its contents nor the array. You see how much you can learn out of one little example? Alright. Next, how does this work? Because this is a template function and the argument of the template, or the template parameter rather, is a size t type thing, then the compiler can and will determine and produce a function specifically for arrays of the size that you pass in. And you'll see that under the debugger. If I simply step into the function, you can tell by its name that it's a special version of this function that takes constant pointers to constant strings of size 4, which is wholly different from the version that takes arrays of size 3. This is quite long, isn't it? Anyway, it's been a while. I'll run up to here and I'll step in. Okay, F8. Now, here's the name of the function. My mouse works. See the W there is a hidden W from a number defined, but the important feature is that this thing here is a function whose name has the number 4 in it, and that takes a constant pointer to constant wcar strings, array size being 4. Okay? So it knows the size of the array. Similarly, this other one, I don't need to specify this size here because it can work it out. The compiler can work it out very easily. That this one too is a version 4. This is a whole new function, even though it's the same code. If I pass an array of size 3, it has to make a whole new function that takes arrays of size 3 as arguments. That way I can never go wrong with the size of the array, and I can never get a memory overrun or go beyond the bounds of the array. I never need to specify the length of the array. That is automatically fixed and made sure of at the time of compiling, not at runtime. And compile time error checking is much more powerful than runtime error checking, because if there's an error, then the thing just doesn't compile. You disallow errors by disallowing the compiling of a program containing an error, at least in this case. How does it work? Okay, first I have now an array of 4 pointers to strings, and I'm declaring something called iFound, which is the length of this string. Okay, I haven't really taken care of the zero length case. I guess I can just return -1. I think 0 will should return -1, but it doesn't need to go through all this. In any event, the length of the string is 35, and this iterate array here is a macro. All that does is here it just goes from 0 to number of elements in the array. Number of elements can be, there are various ways to compute that. One way is to use a built-in thing, count of, which is a Microsoft extension, or you can use a size of array divided by size of element. We get the same answer. So this will only go, this will go from 0 to 3. Okay. Now what I would like to do is search for the first substring, s space a, right, using the function provided here, and that function is called find. You can see it, right? Now this is calling a pointer to member. This is the syntax that you use to call a member function that has been passed in as a variable, a member function of the same class, in this case find. So this should take us into find, which takes as arguments string and start position. So here we are in find. Okay, that was passed in variable. Now there's another find. There's another find here that takes a pointer to string, start position, and this here is this type of function, lock sub ptr. This is something that locates substrings, and it's a pointer to such a function. So, well, I don't know. Locate pointer to substring. Okay, it's not a member function. This is just something that takes two strings and locates a subpointer, a pointer, sorry, within the first string. That is this. No, sorry. This is this. Which one is the substring? Well, we'll find out in a minute. One is the string and one is the substring. We'll see when we get there. Okay, so here we are in this function. The variable function that we've been supplied with is called TsStr, which takes two strings. Now we want to call this. Okay, so the first thing being passed in is the string we're searching within, and this is the substring we're searching for, s space a, and we want to start at offset our pointer plus the starting position, which is 0 in this case, but generally it could be a different offset. So again, here we are in a very using the same code here for another two possible cases, or any case where the location of a pointer substring is a replaceable element of this function. and the one in this case is the one that's been provided. Oh dear. It says that it might not get me to the. Oh, it's the right one. Okay. So now this function is in the runtime library. Okay. So that's where we end up. It's going to, by the time we get here, it will have either located or not a TCH, and it did locate something. Now what I've got to return here is an integer value. So I have to take the returned pointer and subtract the beginning and cast that as an int. Now you might wonder why that works, or you may not wonder. If you are one of the people that wonders about it, like me, the reason it works is because in C, a difference like this is the value of a difference like this is not the distance from here to here. It's the distance, or from here to here, or whatever. It's the distance divided by the size of each element. So if this was a pointer to a bunch of structs, and I took this difference, and the struct size was 100, that difference would be divided by 100. So the return value is in fact an index into the array of whatever. We did find a position 5. 5. Is that where it would be? It could be. I've forgotten the string this line. It's probably in here somewhere. Well, string. This is string. It contains the string. S/A is at position 5, right? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Position 5, 0 based. Even though these are wide strings, wide characters, the result comes back as an index. So this works for a multi-byte or wide character. You get the same result. And so it found one. Next, if we didn't get a -1, and we assigned to iFound the minimum of iFound as it currently is, and what we just found, then we store the index, the found array index, from here into the returned array index passed in. If the assignment here didn't change the value of iFound, that is, if the minimum of iFound and the cause that we just located resulted in iFound, then we don't set this index because we haven't found one smaller than iFound. My example doesn't have multiple finds, but it does in fact work. I tested it in various cases. Okay, so we got our answer 5 and return, and here's our 5. Index 0, right, is the 0th index in this array, which is at position 5 in the string, and we're able to print all that out. Lastly, this hack thing can be made less of a hack, a little bit less, if you use this macro that I have. I'll use it this way. But I'm still left, and you can think about how to fix it. This here, if and declare, is a thing that does the hack without having to rely on the fact that that thing returns -1. I can declare a variable within this statement, and here I've declared it. It's called iFound, and it's set equal to the value of the return of this function. An element I still needed to declare outside. The truth or falseness of this whole thing is given as the second argument in the macro. This is a macro, and if iFound is not equal to -1, I want to go in here. Otherwise, I might do this, and it does work. It does act like an open-ended if. That is, it leaves a dangling if on purpose so that you can put an else. You can do something in the else case. Okay, so this should work as before. Okay, well, that's because the way I did this one is I print out only let's see, mid, the maximum of 0. Oh yeah, I'm printing out just a substring of this string. Let's say it was really long and I just wanted a rough idea. From either found -1, right? Now found was 0, I can't use that, so I have to guarantee that it can't be less than 0 by doing that. And then the length of the substring given by the element found plus 2. So it's 2 extra characters unless it's the very first, unless the found position is 0. 1 character to the left and one to the right, and that gives me a clue as to where that string was. I could do more if I wanted, and then go from -2 to position -2 to position +2. Length of thing. Oh, number. This is a count. This would have to say 4. 4 characters if possible. Now, I'd like to be able to do 3 if possible too. Anyway, it doesn't matter. You have the idea. What one could think of a way to make it easy to indicate where in the string the match was located. The other way being just to print it out from the match onwards, which is probably the best. So that gives something. The best way probably is like before. I found. Now, so this if and declare, that's just a thing I've gone over somewhere in the past. All it does is uses a trick that involves the it involves the use of the fact that you're allowed to declare a bool, any variable, inside of an if. Okay. And here I'm doing if, and I'm declaring this variable called, you could call it any, it doesn't need to have a unique name, in fact. Here I'm giving a special name, but b once would be good enough. And I'm just simply assigning it to false, okay? And it doesn't give you a warning, strangely enough. So assigning it to false makes this a false condition. And then in the else part, which is where the action occurs, a one-off for loop, where in the here you're allowed to make a declaration. That's why it's called if and declare. Right? For loops allow you to make declarations on the fly. Here you can declare a variable and assign it and everything, and then run something to do with it. Okay, so here I'm making a declaration. Now this for loop is going to run as long as this variable is false, right? Okay, so it'll run once. Now I've got another if here. The if here has the variable argument section here, dot dot dot, in it. So you could put multiple things in here. It doesn't matter what kind of expression you want to put in for your conditional. You know, it might contain commas and various things. If this condition happens to be true, then the code following this will get executed, otherwise not. In either case, at the end of the so-called loop, this dummy var thing changes to true. This is the thing to do at the end of each loop. That becomes true, so the condition here becomes false, for loop quits, and it all amounts essentially to a single if, where I've been able to make a declaration and an assignment and do a test all in one line. Unfortunately, I'm still left with this. I could, I think, maybe declare it here. Try it. You can usually declare more than one int on one line because it's an int. It wouldn't work if it was two types of things, but the thing is, n element, well, it might work. The thing that's worrisome is element here hasn't been constructed yet by the time it's being called. I found undeclared. Can I do it this way around? No. Now if only I could declare n element in here. I mean, I could always compound this with a second one, right? Oh, I know. Just set this to this. This thing here is not 0, so therefore this part will get tested. But this else here is no longer. This else does not belong with this if. you would have to say, you would have to be explicit here. Well, right. That's what's really that's the structure really. This is the same as before. Oops. You might get fooled by putting these on the same line and think that the else. You might complain that I've already done that with this macro. But if you look at it closely, this here is already an else, and the last thing on this line is an if. After a for, so the next else belongs with this if, which is the condition that we want it to be true or false. So it is correctly, this is executed when this is false, which is what you want. And if you want me to prove that, I have to make it fail. What did we? Yeah, that has no, that has a match. I think this is, this is SA. Okay, I think I got it. I think there's no more case sensitive matches. There's a one case insensitive match. Two case insensitive matches. 3 case insensitive matches. If we don't get a match, it should print this out, and it will. See? Except now it says equals 0, but in fact, I found is the correct value. We don't have to subtract 1 here in this case because we're not using the hack, which relies on that -1 return. Okay, so there you go. There's a whole bunch of stuff to do with one simple little function that you can think about and play around with and have fun with. The most important thing is to have fun. See ya.